So good morning. You hear me okay? So welcome to my lecture on behaving like a boss with AI in Eve, oddly enough. So small introductions. I am CCP Frellicus of team Space Glitter. Previously I was on 5.0 and did a presentation last year on space components. And these are the in-game characters of my teammates. And the small one, he left, he's a traitor. So no love to him. So if we just get going, I have a lot of slides and diagrams to show you. And I'm going to give you a short overview over what I'm going to be talking about. I'm going to start off by framing the problem, explaining why we did what we did and why we need to do that. Sort of makes sense. I'm going to go very quickly over the tail system and how we use that. We also used the space components from last year to implement the new NPCs. And then I'm going to go into the meat of this talk, which is the behavior trees and how we use those in EVE Online. I'm then going to go over some more specific things, Blackboards, and how we use those to synchronize group behaviors. And then a bit on how we try to maintain reactive control in the behavior trees. And how we try to keep it event-driven. So yeah, we'll end up with some Q&A. So you can hopefully ask questions if I don't take too much time on clicking through these slides. So let's just get going. AI in EVE has not been spectacular over the years. It started off pretty simple. I see you, I kill you. Is pretty much the tagline. They wait for aggression bubble actually. They will just target you, orbit, fire all their guns, and wait for either one to die. And that's usually the red cross. We then expanded that a bit during Apocrypha, when we introduced the sleepers. I was not working on that at the time, but what we did then was we introduced threat evaluation and then more cleverness in how we use secondary targets. So they can actually pick different secondary targets and they try to spread those around. But they're still pretty much doing the same thing. They see you, they activate all the things, and they wait for somebody to die. But they also did another thing. They could actually switch targets. So every once in a while, they would reevaluate the whole situation and pick somebody else to die. So that was a good thing. But this mostly was an exercise in fixing the target evaluation itself, like being clever about picking who to kill. And that the threat evaluation, by the way, is based on both damage dealt by you to NPCs, and damage and also heals, like how much reps you are putting out. And then we also recorded module activations, like E-War, warp scrambles, webbing, and such. And then created a number, which then ranked the players. So how to pick who to die first. So we were not particularly excited about trying to extend that system because it doesn't really scale well. This is a diagram I showed during the space component talk last year. And this is the inheritance diagram of the entity system. And it's a complete mess. And if you want to share behavior between any of those, then it's everybody for its own man-eat-man situation. And if you mess around in this, there's very good likelihood of you actually destroying something else or making something else break. So you might try to make your rat in a belt more clever, and you might actually break all the sentry guns. And that's not a very great situation to be in. The current, or like the old AI was running some sort of a state machine, but it wasn't an explicit state machine. And all the states are shared between all the different, vastly different entities. So a structure would be sharing states with a belt rat and such. So you never actually knew what the state was supposed to represent and what happens in that state and how it gets out of the state or where it goes, or actually who is implementing that state change. So, which brings me to this. So this is a short explanation of how we sort of author our NPC commands. The commands are basically things that deploy the belt rats, what belt rats do appear where. And that's not so complicated. It doesn't look complicated. We have a gin, which is a manager of sorts. It spawns the NPCs, and it spawns groups, and those groups contain then the actual NPCs. And it sort of looks like nice if you put it like this, but the reality is more like this, like a Venn diagram. The commands are pretty straightforward, and they then somehow magically translate into a gin, and then it becomes a complete mess. Like everybody is setting state for the entities and deciding to warp in and activate effects, and this is not a very nice way to work with your logic. You don't know where to implement anything, really. And if you change something, then you're probably breaking a whole lot of things that you didn't expect. So for our changes, what did we actually want out of this? Like, it wasn't super complicated what we needed to begin with. We're not trying to reinvent the whole NPC structure at one go. We're actually just trying to make one specific NPC that needed to do something different. But it also served as a prototype for how to move forward and do more interesting things. So the first thing we needed, we wanted NPCs to roam around the systems. We wanted them to exist outside dungeons. Well, we already have that with the gins, but the gins are a complete mess. So we wanted a different way to be able to do that. We needed some sites to visit, dungeons basically. And we wanted an AI system that we could understand and work with. And ideally, we want to be able to reuse those behaviors that we create in more than one case, so we're not having to do it again and again for each and every entity. So let's start off with how we get the content to where we need it to be. So we introduced the tail system, or during the Sunshine incursions, we created a system that could span multiple systems. These span entire constellations, and we haven't touched this system since 2011, but I actually was part of writing that system, so that helped. What the tail system actually does, it's not very complicated. So we have a distributor that can distribute these tails. They're based on templates. Each tail then can have an arbitrary number of solar systems it deploys content to. And it does that by activating timelines in each system that it's interested in. And you can do that dynamically as well, so you can add later or such. So in the case of the incursions, we distribute to an entire constellation, or most of the constellation, a set number of vanguard system, assault systems, an HQ system, a single one, and then a staging system. And we had some criteria. They couldn't be next to each other, the staging system and the HQ system and such. And then when you finally grant enough influence, we spawn a special timeline, which is the boss encounter. The Kundalani manifest and all that, yes. So that's fine. So so each timeline contains basically different time keys, which contains conditions and actions. So we can actually put conditions like, is it the right security system, or you have system security rather, and such. So let's look at this a bit more. So what we needed to change actually to make our stuff work. Rather than having constellation scale deployment, we created new templates that allowed us to do entire universe scale, which we needed because we wanted to have a distribution over the entire known space for our content. And the content I'm talking about is specifically the storyline content that we have been introducing since December. So we started off with the seekers and the hidden outposts. Then we later revealed the outposts. And we wanted those to remain in space and visible at the same location. So it had to be deterministic. In addition, we also wanted to be able to deploy NPCs through the system, which we hadn't done before because they were just part of the dungeon content itself in the incursions. So we added that. And we also needed a way to deploy these new behavior NPCs that I'm going to describe in the coming slides. So let's get to the entities themselves. Before I could actually start making them behave interestingly, we needed to clean up a bit. So I went the route, we went with the deployable structures. We using space components. I was in the pub for last night, so I'm a bit off. So bear with me, bear with me. Yeah, so we want them component-based. We wanted them to be able to coordinate behaviors between them. And we wanted the behaviors themselves to be modular, so we could reuse them and reassign. So those were the base premise. So which brings us back to this slide. I really like it. There's so many nodes that I can always show this again. So we actually did not want to participate in this graph. And there's only the base entity that had anything of use. But it's so polluted that that did not immediately help us. There were over 150 methods in that base class, which was the accumulation of everything that they needed to share, just drifted up to the base class and make that a complete mess. So the base class knows how to fire missiles and do all kinds of weird things that it shouldn't know about. So what we did, we basically stripped down this entire structure. Did I mention this lecture was pretty technical? But yeah, we stripped down this structure. So we have the base entity. We actually made another superclass on top of that and just took out some navigation code and pulled that into there, like approaching objects, warping. It had some callback mechanism that was actually useful. And we just left everything else behind in the base entity, so we don't interrupt that chain, that inheritance tree. So the pirate drone and all its friends, they just stay the same right now, but we can create our own little behavior entity. And that's a very thin construct. It's mainly there to facilitate event-driven behavior. And it knows how to drop stuff in a rack itself, or actually drop a rack. That's the only thing it does. So it remains a physics object. It's not trying to be everything and all, like most of the entities are trying to do. But that's because we're going to try to make components out of them. So this is basically the component structure, and it's not complicated at all. So the circadian seeker was the first one. We have this dogmatic component, and it's pretty important because otherwise you couldn't kill it, and it couldn't fire any weapons, and it couldn't do anything interesting. It would just stay there and take the pounding forever. And then we have the behavior component. The behavior component itself is also very thin. Its main purpose is just to make sure that the entity registers for a behavior, and it has a default behavior defined, but we can actually override that. We have an override mechanism, so I can now target different behaviors to the same entities, which we couldn't do previously. So every type of NPC had a specific base class, and that defined how it behaved always. But now we can actually swap this dynamically. I usually do it when we actually spawn the entity. It doesn't be useful to do it like in mid-streams, but we can do that now, which is nice, because a lot of manpower goes into duplicating NPCs just so that we can put them in different situations and do slightly different things and give them different names, and that basically creates a maintenance burden for us in the end. So we now have to like manage 10 identical NPCs rather than just one. And then we have like 100 sets of those 10 NPCs, which becomes pretty boring. So the drifted battleship has 2 additional components. It has an NPC pilot, which you might have met, which gives him the icon of the drifter and gives him a name and all that. And then he has a turbo shield, which is a reference to Star Wars, if you didn't notice. So let's get on to the behavior trees themselves. So a behavior tree is basically a method of decomposing complex behavior into a collection of tasks, which is arranged like a tree. And I actually put in the root because we turn the tree upside down and then everybody becomes confused. So it allows us to break down the logic into modules or subtrees, and helps us maintain modularity, or actually have it modular to begin with. And behavior trees they're not new to gaming. They have been around for over 10 years. The first reference I remember is probably Halo 2 or 3, was it? I think it was Damien Isla was talking about behavior trees used there, and some clever bucketing mechanism. But they're getting pretty popular these days, and there's a good reason. That's because it's fairly easy to understand and break down complex logic into something understandable, something you can get your head around. We can also make them reactive, so they can react to situations by re-evaluating the trees, and we'll get into that better. And we can author those. We can create tools to create new subtrees and then piece them together into bigger behaviors so that we can reuse and iterate on existing things. So our combat behavior can be iterated on individually and then branched out to something different, so we can possibly do like a sniping behavior that specifically knows how to keep long distances or warp away to a new point when somebody gets close and that kind of stuff, something that's not possible today. So let's take a better look at what a behavior tree actually is. So it's a tree structure. It has a root, and we start evaluating the tree from the root. It's a depth-first search, really, through the tree, and we evaluate from left to right, always. And that's sort of what gives it a very understandable structure. You can always, like, guide your way through where it would go next. So, and we update it every second, but we actually implemented this as an event-driven tree. So the updates usually don't do anything. If we have succeeded in our task, then the update does absolutely nothing. It just waits for an event and then does something as a response to that event. But if we need to, we can have it tick at whatever speed we really need. And sometimes that can be useful. So a task is a single node in the tree. And our behavior is a collection of one or more of these tasks. These tasks have an execution status. So these trees are very similar in a sense to decision trees, where you make a decision at each junction. but not quite. So they have, when they start off, they're invalid. And when we clean up the tree, they become invalid again. If it succeeds cleanly, then it either like returns a success or a failed status. Failed is not an error. It's just that this node did not succeed, or the result was wrong. So if we have a condition, for instance, like if you found it, then you're good, success. If you didn't find it, then you fail, and you can make a decision based on that. We also have a running state, which is basically makes it do a busy update every tick. That means that it gets updated every tick. But if we suspend it, it just doesn't get updated at all until something happens that makes it get updated. And then we have a special state, which is a blocked state, or a status. And that's a utility that we can use to prevent us from resetting the tree while it's doing something that takes a long time. We'll maybe get back to that. So we have different types of tasks. We have composite nodes, and then we have leaf nodes. Composite nodes are basically what build the tree structure. They have one or more children, and that's what defines them. And currently we have three, well, there are two main ones, the priority selector and the sequence. Then we have a special one, which is a decorator, and we have several versions of decorators. So the priority selector, yeah, I have special slides on this, so let's go to that. The leaf nodes, we have conditions, which just evaluate something quickly. Actions, which actually do something. And then we have a bit of a magical one, which is a monitor. And that's not always a leaf node, because it can also appear as a decorator. I'll have more on that later. So let's just start with the simple ones, the conditions. The conditions are there to query well state. They just check for some condition. Is it nearby? Is the target close? Do I have a target at all? Is some memory variable set? Or something like that. So they're not supposed to have any side effect. They don't change the world in any way. They don't set state. They just query it. And they're just supposed to be in and out. So they always return a success or a failed. They should never be running or suspended or any of that. That's also so yeah, I've colored this similar to how it's done on by Alex Champanard and AI Game Dev. So if you ever look at those behavior tree slides, then you should be pretty familiar with them. So move on to actions. Actions are the things that actually change state. There we are orbiting, we are setting a target, or warping to a location, for instance. Make the NPC actually do stuff. And actions can potentially run for a long, long time. For instance, our basic warping function is a monolithic block, basically. When you start that, you don't want to stop until you actually get on the other end and break out of that behavior, which is also why we have the blocking flag. So let's go to some more interesting ones. The priority selector. So these are these two base nodes that define how we iterate through the tree. So a priority selector will try to go through each of its subnodes in order and see if it succeeds. And it will stick with the one that succeeds. And the order defines that priority. So we're going left to right, and the leftmost is the one we try first. And if that succeeds, we don't try anything else and keep on going. So if any child node succeeds, the parent succeeds. So the first one failed, we try the next one. If that succeeds, we're good, and the whole tree succeeds. or this subtree, as this is just a subsection of some generic tree. So if all of them fail, the whole behavior fails. The whole priority selector will fail. But if you suspend, or actually if the child task keeps running, it doesn't return anything yet, we actually suspend the task, and it doesn't do anything. So we don't have to do any work at that point. It's all going to happen in the subtree below it. So let's move on to the next one, which is a sequence. A sequence will basically just try to go through all its children while they succeed. So if any of the children fail, the node itself will fail. And at the same time, yeah, if all of them all succeed, the whole behavior succeeds. So this is based like doing a sequence of actions. If you can manage to do all of them, you're good. If you fail at some point, the whole sequence fails. And the same thing here, we just suspend if any of the children are running. We don't do any work while that until it actually completes, and then we switch to the next one or terminate. So another composite node is the decorator. And a decorator is sort of a way to modulate or affect a subtree. So we can like invert the logic. We can invert whether it returns success or fail. We know that the subtree is supposed to return a failure, but we actually want to interpret it as a success so that some other logic works. We can implement cooldowns this way as well. So then we can just put a timer on the whole subtree, so it will only run once every minute or so. We can also do a blocking behavior, and in some cases that's very useful. So we want to do something atomic, like we want to execute the whole subtree, and we don't want anything to interrupt that. We're playing some sequence. So it won't unblock until it actually leaves the subtree. It makes it, basically, it's almost like a transaction, except we can't roll back, really. We can also do repeaters this way. Like we want to create a behavior, like I'm trying to target somebody, it fails, he's out of range, I'm going to repeatedly try that until it succeeds. Or you start trying to target while you're out of range, as an example. Yes. I have a lot of diagrams, so I'm just putting this picture just to break it up. This is the secret if you haven't met him yet. Cute little Wall-E-like monsters in space. So let's move on. Let's go to Blackboards. So for all these nodes in these behaviors, they want to share some state. So in a tree, we want to work with a variable, we want to set a target, then later we want to fire at that target, orbit it, and such. And we use a Blackboard for that. It's a sort of fancy name for a working memory for the entity. But it also does some other things as well. So it allows the task to share data, as I mentioned, but it also provides us with a publish-subscribe mechanism. So we can post the values there, and we can subscribe to them as well. So we can have some node just watch the combat target value and wait until it actually updates. So if somebody changes it, then we will know and can actually do something about it. And that helps us keep the tree reactive and event-driven as well. So each update can actually become an event. You set a value, and that triggers something elsewhere. And this is a screenshot from our in-game debugging tool. And you can see some example of actual variables that we're using for the seeker to analyze, amongst other things. Right. So another feature of the Blackboards is that we have different scopes, so you can have multiple Blackboards. And what we do is that each entity or each NPC has its own Blackboard, which is uses mostly internally to communicate between the tasks and behaviors. And then we have a group Blackboard, which is shared by the spawn group. So if you have 4 seekers, they can all share a single target. And this allows us to do group behaviors and shared behaviors. So we're actually be able to synchronize through that. So this is sort of the structure. You have an entity on the bottom. They have their own Blackboard, and then they all have their shared Blackboard. And that's how they can actually share values and communicate. So here is an example of how we can synchronize a behavior. So this is an exploration behavior that basically implements roaming. So this would be a subtree in a larger context, and I'll get to like how we compose bigger behaviors in a while. So we start with a sequence. We just run through these in order. And the first leg, we have a decorator, which forces it to always succeed, and there's a trick to that. That basically means that it will always go to the next one, regardless of what the result of the first execution is. So after that decorator, we have another decorator, which is a cooldown. And this cooldown is implemented through the shared group Blackboard. So they're working on a variable there. So that even though you have 4 different entities, they all want to work somewhere, and they have a timer of some minutes between when they pick a new place to go and visit. So only the first one that actually goes through this tree will go through that cooldown and get to the action and find a new location to visit. He will then post that to the shared Blackboard and then move on. He will have a new location because he just set it, unless he failed, and then the whole thing fails anyway. And then he will check, like, am I in this location already? If so, then I don't need to work there, do I? And if that is false, basically, it's not in the same location, then we will execute the warp. So we're working on shared variables between all the entities. Only one of them will actually go and set the variable, because of the cooldown will have locked after that, and they will just proceed to the next one. And the next one is actually a monitor. It's not a, so the orange one, they're special conditions, and I'm going to describe them a bit better later on. But they can monitor a variable, and they can actually reset the tree. Like, somebody set this variable, you should probably reevaluate your whole way of thinking and try to figure out what's best to do right now. And that's really what the behavior trees do. You evaluate from the top, and it will figure out, given my present situation, what should I be doing? So this will basically make them all travel to the same location. So how do we do the modular thing? So what we can do here is we have basically a priority selector, and then we can have different sub-behaviors. And this is sort of borrowed from like a fairly standard FPS sort of way, where you have 3 basic behaviors. Like it's fighting, it's suspicious, or it's idling. And this is in prioritized manner here. So the most important thing is to survive and fight if you have to, like the fight or flee. So that's first. If you don't have to do any fighting, good. Then you go to the next one. Do you have any reason to be suspicious? Did you hear any sounds in the woods? Gunshots or anything? If not, then you go into the idle behavior. And that might be like patrolling some waypoints, lighting a cigarette, doing menial things. Like and what we usually want to have is some sort of a fallback behavior that you can always do regardless of where you are. In that case, your NPC doesn't look stupid if it has nothing to do. So it just goes and smokes a cigarette. You should try to look at the seekers when they're doing nothing to see if they actually go and smoke a cigarette. So in our case, it's closer to this. We don't have a suspicious behavior, but we do have fighting, and we do have some idling. And you can see that I put reinforcement right in the front. In terms of survival, you want to call your friends before you get killed, probably, before you get sucked into combat. And then we have the super weapon. Excuse me. Excuse me? I should, but I only have water. I will after the lecture. You bet. So, yeah, survival first. And then we make the super weapon override normal combat because otherwise it would forget to fire it and everything would be sad. And nobody would die. So, and the super weapon is actually, it's triggered off the turbo shield component. So it's actually event driven. It doesn't do anything unless the shield goes down. And if the shield goes down, it gets very angry. And that makes it reset the whole tree, figure out that it should be killing somebody really quickly. What did they say? Blast someone really quickly. So, and if it doesn't have to do any combat, we go into exploration, but we only do that every once in a while. So that's basically the behavior I showed you before. So if there's not time to move to a new location, we will just go into the idling, and then they will go and scan some space rocks or players or whatever else they find. And if there's nothing to scan, they will just mile about and smoke a cigarette. So let's get to the monitors I've been looking at. So the monitors, they sort of break the rules a little bit because they can monitor a state after we've actually left the node. So in this case, if we visit this orange node and go to the action, it's still going to be active even though we left that. We're not in that subtree anymore. And it will remain there until we actually reset the whole tree. And the usual purpose is that these monitors are supposed to reset the tree when something triggers. And we basically put them in as some sort of like tripwires. So let's say we have an NPC in an astral belt mining some rocks, happily blasting at some rocks. And that would be in the idle behavior, because that's what it does. When it has nothing to do, it goes and mines rocks. And somebody attacks it. So we have a condition somewhere that says it's under attack. So what we don't want to do is have that condition in the idle behavior, like while we're evaluating that subtree. It sort of breaks the encapsulation. That means that we are suddenly pulling combat behavior into our idle behavior. So if I have a miner that can't do combat at all, then suddenly I have a bunch of conditions that are completely unrelated to that behavior. So I don't want that. What I do want to have them is in the combat behavior itself. But I've already left that behavior usually, and I'm stuck somewhere in the bottom. Excuse me. I thought I deleted that. oh, well. So what we do basically is we leave, we visit a monitor. It's going to leave an event. So go sign up for an event, and it's going to keep that alive while we visit some lower priority behavior. And what usually happens then is if that event triggers, we usually don't change any state as such. We just tell the tree that it should reset. In the next iteration, it's going to clear everything, forget what it's doing pretty much, and just assess the whole situation from the top again. So then you will go back through the structure. Should I be reinforcing? Did somebody die? Should I fire the super weapon? Was it the shield that went off? Is there combat? Oh, yes. Aha, there is combat. Somebody attacked me. I should probably be fighting now. So that basically allows us to pull out of this idle behavior and go into a higher priority behavior to do something interesting and get killed, probably. So yeah, it keeps the tree reactive. It can react to changes, and it maintains the encapsulation of the behavior. So we can keep our guard triggers with the behaviors that match it. So we are now getting close to the end. So we created some debugging tools to be able to monitor this. And this is a screenshot of that. So you have the tree here on the left, and then you have both of the blackboards on the right side. So you can see the item blackboard and the entity. And the colors are the same colors I posted on the statuses of the trees, and telling us in which state is each node. So the green ones, they succeeded. The red ones, they failed. And the purple one is suspended. So the only ones that would actually be ticked normally in an update, if everything is suspended, then nothing happens until somebody finishes and basically sets something in motion. And here we're into some combat. I attacked the chip. You can actually see the laser there behind. So this is an in-game tool. So you can see through the window because it's just an e-window. So here you can actually see that in the combat sequence, everything is green. Posted a bunch of things to the Blackboard. It's monitoring some states there. It's tracking, so you have a target lost monitor, for instance. So if we actually lose the target, we're definitely not going to be trying to keep killing that target. So we then want to reevaluate, pick a new target, and attack that target. Then we trigger all the facts, we orbit, we try to target them, and then activate all our, we mash F1 furiously. So, right. So this is pretty much what we have done and what we have been introducing with the sleepers, with the seekers, circadian seekers and the drifters so far. And we're going to be continuing this and possibly roll this out to more areas. So the next thing that I'm going to be working on is actually creating the authoring tools for these, so that I can try, at least, to have my designers create behaviors, so I can focus on the specific things. Because a lot of this is reusable, both the nodes themselves, we create, set a value, activate an effect, and such. And then you can create entire subtrees, like the combat mechanic or the roaming mechanic. Like we could roll out the roaming mechanic just for some random NPCs, and they would just go and be a space yacht flying around the system or something. So that's becomes really easy to do, rather than try to extend some weird subclass that we don't even know how to behave. So yeah, more behaviors and more behaving things. So yeah, that sort of concludes my content, and I guess I'll just open up the floor for questions if you have some. I think our time is almost up. But, any questions? Yep. Is there a mic? Not in a straightforward manner. If we just roll out a super complicated AI to everything at once, we will upset the balance of everything, and we will have a complete shitfest on our hand, I would expect. So we will have to be a bit more careful. We will probably try to replace or create new missions which have more interesting NPCs, maybe do new burners or something like that. So try to roll them out in a more targeted manner. We might take areas and replace the best rats or something like that, so that we don't just change everything and we have a completely unknown state at our hand. But who knows? Apparently risk is a thing these days, taking risks. Eventually we want to have more varied behaviors, definitely, yes. You, sir? Yeah. So I could actually use it to control them. Yeah, I mean, yes, we have seen that. We were, for instance, surprised. We created a behavior which was basically meant to make sure that they work to the same location and try to fight there, but it ended up that it actually followed players around, and we kept it. That's interesting. But that was a surprise also for our QA when suddenly it's here and attacking me. So, and also we had a very interesting case where they started attacking posses, and then somebody got a really bright idea that how about fighting back from the poss, and activated the poss guns and shot at them. At which case the Seekers actually attacked the control tower itself. And I'm keeping this one. They actually, you have to bring them and lure them over to be able to do that, so it's your own fault. Excuse me? At the poss? The poss will hurt, but I'm not sure it will die, but it will hurt very badly. You, sir? No. The burners are, they're using the regular AI. But we have been a little bit creative in the module category there. I think we tweaked a bit how the afterburner effects worked. I'm not sure. I haven't been in touch with that for a while. But no, but we would like to, because these are sort of a puzzle entities. So currently it's sort of a fitting puzzle. Like you have to fit right and have some skills to be able to break them. But if we can actually change the behavior as well, so that they can warp out, or they can cloak up, or do interesting things, then we can basically create more versions of these targeted puzzles, sort of, which would be interesting. You? Randomness, currently it hasn't been requested as such. So I'm mostly following what our designers want. It's a nice way to drive this, but we're building up the capabilities as we go along. But that's certainly something that we would like if we roll out a generic belt rat, we probably want to have it show a bit varied tactics in the end. But currently we haven't been focusing on combat tactics as such, but more of being able to do different behaviors, not just firing weapons and orbiting a target. Yeah, exactly. the seekers actually do that right now. But it's, yeah, also unpredictability. Should it always be the case that they work, or should they maybe try something else? That's definitely something I want to look at, but we haven't had time so far. You? They don't leave the system yet, but I'm not making any guarantees. They actually might. But they hunt you. They can hunt you into mission sites and all kinds of places. You need to aggress them currently for them to show you any like proper interest. But you should go and look at all the nice space structures in close up. Then you get their attention. So in the back, you, yes, Quaif.
I saw the reinforcement authorized attribute. Does the trigger entirely new spawn, or can you also basically call in other entities already in the system?
Currently, we're adding new entities. They're not calling in other entities, but we could do something like that. But right now, we're not. You, Orange?
Have you programmed any retreat mechanism? Retreat, regroup, reattack?
Not as such, but related to what the other gentleman behind you was saying, under certain circumstances, like under E-War, they have shown different behaviors. And not being able to target anything, the combat tree failed, and they decided that this was not a good place to stay in, and they walked off. So that was one example of emergent behavior that comes with it. Any more questions? I think we're pretty much out of time. There will be a panel at 2 o'clock, was it? At 2 o'clock for the NPE segment. So if you have more questions on AI or NPC behavior and related questions, then just show up there and we can continue this conversation. Thank you for coming and listening.